doing today? That was a great introduction from Michael. I have to admit, I'm on a web high this morning. Despite the fact that I had to skip my workout and drive an hour and 15 minutes in rain, I passed a really bad accident, but I'm still feeling really, really good. I love this conference. This is the third time, I think, that I've spoken here. And there we go. There's my kids, two of my kids. Okay, I don't need a network. Well, I love coming up here. Before I came up, I was talking with Eric from Shoutlet, about tracking analytics on social media. Very, very exciting opportunity. He got me so pumped about that I wanted to announce I'm actually retiring from web performance and joining Shoutlet. April Fools. It is very exciting. I'm not joking about that, but I really love web performance, so we're going to stick with that. And I saw Xero. Anne mentioned Xero is here. I love them. They're from New Zealand. I know Craig Walker. Maybe he's here, so hopefully I'll get to connect with him, encourage people to go down there. But I really wanted to give a shout out to Anne. I think she's right about what she was saying about how this event has grown, a very community-driven event, and she and her crew do a fabulous job. So could we have a round of applause for Anne? So today I'm going to talk about that quixotic mercurial web that we all know and love. I worked on this talk over the last few days quite a bit and had some fun discoveries. And that's what I love about this job is I've been doing this for 8 years, and I can spend time researching for a talk and find something that I was completely oblivious of that is pretty important just over the course of a few hours. So let me go ahead and get started here. There we go, we got that. And I wanted to point out the slides are on my website right now. If you go to stevesouders.com, I have all my talks listed and the slides are next to them. So you can download the slides now or later. Later might be better than all of us trying to download them now. So I don't know about you guys, but for me, I don't like slow. I don't like waiting. I find it really frustrating. Here's where I was 2 weeks ago with my 16-year-old daughter at DMV, standing in line, and they need to adopt some best practices. It is not a great experience. I think we'll all agree, slow is not a lot of fun, right? Whereas fast can be really exciting, right? It makes us smile and laugh. It's exhilarating. We like doing it with friends. It can be beautiful, and it just puts a smile on your face, right? How many people like fast? Okay, so what's this have to do with the web that we all know and love? Well, it turns out that people want fast on the web too, right? Now, how does that come about? Well, we certainly are familiar with these very prominent ad campaigns. Here's one from Comcast talking about Xfinity, and it's got speed, lightning fast all over it. Here's a great series of commercials I love where the very deadpan guy is interviewing these kids. What's better, one thing or two, doing things at the same time or not? Faster is better is the bottom line. And it's not just our connections, right? It's the devices themselves. They're getting dual CPU, quad CPU. Those CPUs are faster. So we're getting faster devices as well. And so these ad campaigns are feeding this desire for having things fast, this innate, visceral desire not to have to wait for stuff, right? And we can see that in this chart I pulled from Joshua Bixby's blog post last week. These data points are from 4 different studies. If you pull up the notes in the PowerPoint deck, I've got the links to all 4 of them. And they just show how the user expectations for how long they're going to wait for a web page to load are getting shorter and shorter and shorter. We've got to deliver those pages fast, or we're going to drive the users away, create a negative brand image in their mind, right? We're going to have high bounce rates. So we've got these major ad campaigns advocating the desire for speed. Users are reacting to that. They want things faster. And companies also have produced these case studies where they show that making things faster is better for their bottom line. So I've got about a dozen of these that I went through actually last time I spoke here. I'm just going to touch on 4 of them really quick. Here's one from Bing where they saw that if a search result page was 2 seconds slower, they lost 4% revenue per user. Here's one from Mozilla, making their landing page 2 seconds faster, increased Firefox downloads by 15%. Here's a great one from Shopzilla, making their site faster, increased conversions by 7 to 12%, depending on which country you're in. And here's a more recent one from BarackObama.com. Kyle Rush will be speaking at Velocity coming up in June. And he made their site 60% faster and saw a 14% increase in donation conversions, right? So speed does have an impact on how users engage with and embrace your website and your brand. So how fast are we actually going, right? What I want to do today is I want to talk on various components of that experience, that web experience, and talk about how we're doing over the last year or so in that area. So first, let's talk about connection speeds. So I'm going to pull data here from this awesome quarterly report that comes out from Akamai. Akamai, as probably everyone knows, is a CDN, #1 in the industry, tremendous worldwide presence, tremendous number of websites, major websites using them. And for about the last 5 or 6 years, they've produced this quarterly report they call the State of the Internet. And in that, they include connection speeds broken out by major cities, states, countries, and globally, right? So I went back over the last few years and created these charts. So here we see global and US average connection speed over about the last 5 years. So I just want to look at year over year. If we look at year over year, the average connection speed globally has gone up 4%. And in the US, it's gone up 18%, which is pretty significant, especially if you consider that our connection speeds here in the US are more than twice as fast as the global average. So that's significant progress there. If we break it out specifically by mobile, we see even greater improvement. Now, I want to talk a little bit here about these pseudonyms that are used. Akamai doesn't want to reveal stats for specific mobile carriers. So what they do is they assign each mobile carrier a pseudonym. US1 might be Sprint or T-Mobile, I don't know. But across all the reports, that carrier's name is kept consistent. And so what we can see is for the 3 major carriers, US1, 2, and 3, year over year, their average connection speeds have gone up 68%, 131%, and 30%. So if we look at connection speeds, year over year, we're getting a 4% increase globally, an 18% increase in the US, and on mobile, depending on your carrier, 30 to 131% faster. So that's pretty good, right? Pretty good progress. To me, mobile could always be faster. I think Michael will agree with me. How about browsers? So I don't want to open that Pandora's box about which browser is the fastest. More here, I'm looking at year-over-year comparisons. I'm looking at trends, the trajectories that we're on. And what we see is that browsers, as we get new releases, browsers are getting faster. Those new releases are faster than the old releases, thank goodness. This is a really tremendous study. Unfortunately, it's about 1.5 years old. It's from Gomez data, which is part of CompuWare now. And they haven't revived this study. They haven't updated this study, unfortunately. But this data is based on RUM data, real user monitoring, which means it's measured with JavaScript inside the page of their customers, and they're gathering that data from real users who are engaging with various types of pages from different network connection types on different types of hardware and devices all around the world. So this is very, very accurate ground truth data. And what we see is that as we get new versions of Chrome, of Firefox, of Safari, of IE, those page load times are getting shorter and shorter, faster and faster. So that's a really good thing. We love seeing that. But that's a little old. It's about a year and a half old. So I wanted to also talk about browser performance in terms of JavaScript. JavaScript is a major component of how fast or slow a web page is. I did a study I talked about recently where I turned JavaScript off and on and compared the performance of the Alexa Top 1000. And with JavaScript turned off, pages were 30% faster. So JavaScript is a major component of how fast a page is going to appear for users. And what we see here, again, is the trajectory. I don't want to debate about which is the fastest browser. I'm just talking about trajectories here. As we get new releases of browsers, they're getting faster. If you look at the SunSpider benchmark, if you look at the V8 benchmark, again, that trajectory is going in the right direction. So browsers overall are getting faster as well. So that's a good thing. How about page weight? Okay, so here I'm going to pull data from the HTTP archive. The HTTP archive is a project that I run. I started about 2.5 years ago, where twice a month on the 1st and 15th, in fact at 2 a.m. this morning, the cron job for the first kicked off. I crawl right now about 300,000 of the world's top URLs. And I gather information from that. A lot of it is related to performance. I gather the number of requests, the size of those requests, all the headers for those requests. Did they do caching? Did they do gzip? And also capture screenshots of the page loading, timing information. So I encourage you to go, if you haven't already, to go to httparchive.org and check that out. So here's the chart that I have for trends. I got the URL there in the bottom. And this shows that year over year, comparing March 15th last year to March 15th this year, pages got 327K bigger, 32%. So that's pretty significant. But I actually don't want to look at this chart. And the reason is because it's not comparing apples to apples. As I mentioned, today and for about the last 4 or 5 months, I'm crawling 300,000, the world's top 300,000 URLs. But a year ago in March, I was only doing 70,000. We're growing the number of URLs as we get more hardware, as we enhance the database schema. On our way, I want to finally reach the top 1 million URLs. So we're not really comparing apples to apples. And it's possible that by changing the sample set of URLs, it's having an effect on this data. And I think that's definitely true. What I've seen, I spend a lot of time looking at this data, and today so will you. What I find is that we have better performance best practices as we are closer to the top 1,000. And as we go out to the tail of websites, those performance best practices drop off. And so one performance best practice is to have fewer requests and smaller page weight. And so it might be that one reason why this number is going up is because we're going farther and farther out to that tail, which might not have as high performant websites. So luckily, there's a way to get around that potential bias and do apples to apples comparison. And that's by, in the UI, you can select to look at all the URLs, or you can pick the top 1,000 URLs. So here's the chart for total transfer size and total requests for the top 1,000 URLs worldwide, based on Alexa.com. And so what we see is, over the last year, the top 1,000, the average page weight has gone up 368K. It's gone up 44%. So that's really, really significant. That's a huge amount of growth. It's gone from about 830K to about 1.2 meg. Really, really tremendous growth, which isn't really a good thing, right? This is going to be harder for performance to deliver that in a timely way. I don't have mobile stats here. We actually have a mobile version of HTTP Archive that uses iPhones. Right now, we're only doing 5,000 URLs, top 5,000 URLs there. We could look at that chart too and see what that says. But I think we're going to see similar growth there as well. So that's hard on a mobile device, which is already has challenges, and also people paying for those bytes in their data plans. So this is quite a bit of growth. What accounts for this growth? Well, I know just from looking at this data frequently that images are the biggest component of web pages today. We see that the number of the transfer size, the number of bytes for images went up from about 490K to 640K, 150K increase year over year. That's 30%. And I also know that JavaScript is a really big component. And byte for byte, JavaScript is much more difficult for performance because it has to be parsed and executed. It takes CPU as well. And we saw that that grew from 165K to about 210K. So a 37K, 22% increase year over year. So that's significant. That represents a significant performance challenge. And if we look at the major content types that I'm tracking, if you go to that URL, you'll see charts, trend charts for each of these. We can see, again, the total went up about 368K year over year. Images went up 150K, JavaScript 37K. Flash, HTML, CSS went up a little bit, not that significantly. But if you add these up, it doesn't make sense. All of these major types that I'm tracking only add up to 208K. But overall, the average for total page size went up 368K. Where's the other 150K? So I discovered this Friday when I was working on the slides. It's like, this is interesting. So I started poking around. What I did was I added a chart, which didn't exist Friday, but exists today if you go there, for what I call other. So the way that I track these different content types is I look at the content type response header, right? And often that will say text script or image GIF or some text HTML. And sometimes it's not clear what the content type is trying to say. So for those ones that aren't clear, I classify them as other. And when I started the project 2 years ago, even a year ago when I looked at it, classifying those as other was fine because it was a small number of K. It was a year ago, it was 16K. Well, guess what? Over 1 year, that other category has gone from 16K to 165K, 149K increase, 930%. This is interesting. This is why I love working on the web. Okay, who is interested in figuring out where this is coming from? A 900% increase? Are you kidding me? What is happening? Okay, so what I did, all of this stuff is in MySQL, all of the code and the data is open source. You can download it. There's a few hundred people worldwide who download it on a regular basis, the dumps, and do their own analyses on it. So I've got that MySQL database at my disposal, so I start doing some queries. So I tried to find the content types that were either showing up a lot, like they had a large number of resource requests across this top 1,000, or they were huge. And here's the top 5 that I found. So if we look, video XFLV. So if you remember before, I was just tracking Flash. I was looking at Swift files, right? So pretty clearly, I should really change that chart to say video. And these pretty obviously are easy to track, video XFLV, video MP4 to throw in there. But I wasn't doing that before, and a year ago and earlier, these hardly existed at all. Let me point out let me explain a little bit, there's a lot of numbers up here, what these numbers mean. So in each of the table cells, the first number is, out of these top 1,000 URLs that I hit, how many requests had this content type? So for example, for application JSON, about 30% of the URLs had one of these requests. There were 299 requests out of the top 1,000 URLs. The average size for each application JSON response was 4K, and that's transfer size. And if we take the average across all the pages, how much did it contribute to the average page weight? And so this is pretty simple math. It's about 300K. It's about 300 requests at 4K each. That's 1.2, 1,200K. If I divide it by 1,000, it's 1.2K per page on average. So rounded off, it's about 1K. It contributes per page to the average page weight. And if we take the delta, between March 2013 and March 2012. The delta in K per page is 1K. So we can see the growth of each of these content types that really didn't show up very much before. We can see how much those have grown over the last year to contribute to the average page weight. And the top two are these video formats. Now, they're not being used that much. A year ago, there were 7 resources. This year, there's 29. But also, the size of them increased by 3x, and the size is huge. Why are they huge? I don't know. But now we have 4 or 5 times as many of these video formats, and the size has really increased. If we look at MP4, it's gone up 10x. So the average amount of bytes that they're contributing to the average page weight is really huge. Then we have, but it's pretty clear what those are. Those are video. Then we have text plain, which has grown significantly as well. It's gone up about 25% in number of requests, but the size, again, has gone up 4x. And application octet-stream. To be honest with you, I can't look at those. I spend a lot of time looking at these stats. I can't look at those and tell you what those are for. Are they images that just have an incorrect content type? Are they some kind of binary data? I don't know. My first guess is there's fonts, right? Because they're fairly significant size increase. So let's explore each of those. First, we'll look at text plain. Oh yeah, so if we add up these top 5, we had 150K that was missing. If we add up these top 5, they add up to pretty much 150K, 136K. So there's some other mystery content types, but they're not contributing that much. These are the top ones. And actually JSON, although the size has doubled, it's not contributing that much to the average page weight. So the video are, what about text plain and application octet-stream? Let's look a little further at those. So I do some more queries. I look at the actual file extension. I look at the name. I look at the site that's hosting it. And I can see that for text plain, it contributed 35K per page to the average page weight. 31K of that were for files that were video. 4K were for files that were fonts. So and there were some others. There was some JSON and JavaScript and HTML and XML, but they were pretty small. I mean, the 31 and the 4 add up to the 5. So there's some rounding here that's going on. But the other responses really weren't that significant. These are the significant ones. And if we look at application octet-stream, you can probably read the handwriting on the wall. 19K per page. This content type contributes to the average page weight. 15K of that are for video files. 4K of that are for fonts. So what we're seeing is these mystery content types that weren't text plain and application octet-stream are largely for video files. And these other content types that I wasn't tracking a year ago, they weren't that significant, have now grown a lot. And so if I factor this back into the original stats that I showed and create these new categories, instead of Flash, I'll call it video, and I'll add fonts. And we can see other now has gotten a lot smaller, but images have had tremendous growth. Video has actually surpassed JavaScript as the number 2 largest number of bytes on the average page, and JavaScript has grown significantly as well. And all the other ones have grown, but those are the top 3. So this was a really, really exciting discovery for me. Video is not something that I've paid a lot of attention to in the past. If we look at these year-over-year stats, looking at the transfer size across the top 1,000 URLs, there was significant growth, an increase of 368K, 44%. Images are still the largest number of bytes per page, and they had significant growth, but video went up 150% and account for a large number of bytes on the average page. So this is something I think going forward that at least I, and I think all of us should look at to see. I don't know a lot about video compression. I mean, these files are 1.7 to 2.2, 2.3 meg each. Is there some video compression technology that would help to reduce those sizes? The other thing to keep in mind is the way that this HTTP archive crawl happens is we have these headless browsers. In this case, we use IE9 for the crawl today. There's no user interacting with it. It's not like the user clicked play. So just by loading these sites, it triggered the download of a 2 meg file. Does that make sense? Does that happen on mobile? I don't know. I just discovered this Friday. I've only done a little bit of investigation. But people want to know. These are things that we need to figure out. And my guess is we don't have a lot of well-established best practices around video out there. It is accounting for a large amount of the data on the web, and there are some best practices that we can identify and push and evangelize for adoption. Okay, so when it comes to page weight, things are growing fast. It's getting harder and harder for performance. How about quality of craft? That's what I'm all about. Evangelizing these best practices. Michael gave a shout out to YSlow. We have PageSpeed is another tool that's out now. And PageSpeed actually is integrated into IE9 running in the HTTP archive. So this is another trend chart that you can see the average PageSpeed score across these top 1,000 URLs. Looks flat. Anyone disagree? It went from 82.4 to 84. Well, we can stretch and say that's a positive increase. It's in the right direction, but I mean, it's pretty flat. As a guy who's evangelizing best practices, this is pretty disappointing, right? And in 84, I'll be honest with you, PageSpeed is today pretty lenient in giving out grades. In 84, pretty much you should get an A. Like if you're paying attention to performance, you should get an A, a 90 or higher. And 84 is not a great average score for the top 1,000. So this is pretty disappointing. And there's lots of other kind of quality of craft charts that we can look at in the HTTP archive. Number of DOM elements is one of the highest correlated variables to page load time. And we see that the number of DOM elements, the dotted line on the bottom, is increasing, right? From 1215 to 1330. Doc size, you can't really say what would be the preferred direction for this to go. On one hand, you'd want the average size of the main HTML document to get smaller, because that has to be downloaded, unless people are doing document flush, that has to be downloaded to kick off all the rest of the page. So if you made it smaller, it could be downloaded more quickly. But people might be adopting best practices of inlining small snippets of images or JavaScript or CSS, so we might expect to see it grow. Here, we kind of see neither. Again, it's pretty flat. It went from 24K to 26K. So we're not doing either of those best practices. We're kind of just having a gradual feature creep sort of behavior for the average document size. Again, not very promising. How about number of domains? In this new stat that I just added a few months ago, max requests on one domain. Okay, what does that mean? Okay, so number of domains, this is the number of unique domains or DNS lookups that the page has to do on average. So that went up. Now, DNS lookups take time. Maybe not a lot of time, 50 to 200 milliseconds, but they take time, and it went from about 15 to 19. And this is largely due to the proliferation of third-party content on websites. So that's not great for performance. We're having to do more DNS lookups. But the other one is also pretty disappointing. So this is, if you look at all of those 19 domains, how many resources are requested on each domain? This one might have 3, this one might have 1. It's just a beacon for some analytics. And we look at the domain that has the largest number of resources on it. And that number is the max requests on one domain. We track that most used domain. We track that number of requests on one domain. We take the average, and it, again, was flat. It went from 40 to 41. So this isn't good, because we know that most popular browsers only download 6 requests in parallel per host name. So worldwide, the average to fetch something that's a few K is about half a second. So we can do 6 every half a second. So we can do 6. Imagine I have 6 fingers. The people in the back can't see my fingers anyway. I have a 6th finger, April Fools. I appreciate the minimal reaction there. Okay. I know some people are still awake. Thank you. So imagine I'm doing 6, and each of these take half a second. If the number one domain, most used domain, has 40, I've got to do 6, 12, 18, 24, 30, 36, 40, right? I've got to do 7 of those, and this just assumes they all take the same amount. You're going to have some that are faster, some that are much slower, but if they all take that same amount, I've got to do 7 about half a second sets of loading 6 at a time, and that's going to be about 3.5 seconds. So there's no way worldwide these pages can get under 3.5 seconds, right? And we want them to be like under a second or two. If you look at that user expectations chart, if you look at where people start leaving your site, what drives conversions, you got to get under 2 seconds. There's no way these sites are going to get under 2 seconds worldwide, right? So a technique for this is something I call domain sharding, where your domain might be shoutlet.com. You might create www.1.shoutlet.com and www.2.shoutlet.com. And split the resources. 2 is the best number, is preferred number. Lots of studies have shown that. 2 to 4 is good. 2 is a good safe bet. Split it across that. And so instead of having 40 on one domain, you'll have 20, and you would have to do 6, 12, 18, and then just 2 more. So it gives you a possibility of getting under that 2-second time, right? We're not seeing that happening. People aren't doing that. Okay, what else could we look at? How about making things cacheable? Add an expires header. You know, I wrote that in high performance websites 6 years ago. The percentage of resources that have cacheable headers is actually dropping. This is the wrong direction to be going in. And this is all across the top 1,000 websites. How about turning on gzip? That went up 1% from 76% to 77%. Again, pretty flat. Pages with errors. Errors don't really affect performance that much. It could if it's a JavaScript or a font file or a style sheet that's taken a long time to time out to generate that error. It can affect rendering. But the pages with errors has stayed about the same. Redirects are costly. Again, I was talking with Eric about that right before the conference. And the percentage of sites that have at least one redirect has gone up. So if we look year over year at this quality of craft, really no significant change. In fact, a lot of the trends are going in the wrong direction. So this makes me very sad. Okay, how about if we look at something that's closer to what we actually mean by how fast the web is. If we actually look at how fast pages are loading. Now this is a tricky thing to look at. I'll use Joshua Bixby as kind of a scapegoat here. Love Joshua. He has a great blog. I read all his blogs. I tweet his blogs. Very informative. President of a great company, Streamsloop Networks, that just got acquired a month or 2 ago by Radware. He's still blogging. He wrote this blog last week. Top e-commerce sites are 22% slower year over year, right? Kind of startling headline, surprising. You know, have they come to HTML5 DevConf to learn about these performance best practices? But I have to say, I questioned the data behind this. And it's for the same reason that I pulled this chart out of the HTTP archive. If you go there today, you won't see this chart. It's because it was too noisy. So this is average page load time and start render time for the crawls that we do. A year ago, we were doing 70,000 pages, and we load each page 3 times. So a year ago, we were doing about 200,000 page load time measurements. Now we're doing about a million of those. We're doing 900,000, plus we have some other websites people have added. So we're doing about 930,000 measurements. And we're taking the average across a really large amount of data across 300,000 different sites that have a lot of different behavior about how they're structured and the content that they have. And yet look at how bouncy this chart is, especially certainly there's a hard to explain spike around February 1, but even around the September-October timeframe, a 1.7 second jump up and then a 1.3 second drop down, just from one crawl to the next. And it's hard to explain these. Like if you Pat Meenan, the guy who runs Web Page Test, and works on HTTP Archive with me. We spent hours and hours looking, trying to explain this, and there are a lot of good potential explanations. We're in a data center. That data center showed signs of being congested. We had a lot of, we increased the number of user agents that we're testing. They have to get their requests for jobs. That has overhead associated with it. We're capturing video of screenshots loading. All of these things we investigated, and really it's hard to identify. But what it comes down to is this data is based on synthetic measurements. We're scripting user agents, and just because of the scalability of the job, this synthetic environment that we've constructed has too many biases in it. It's too limited. We're only using one browser. We could use others. Web page test supports Chrome and Firefox. We could use others, but we just don't have the processing power to run all of those and get to this 1 million URLs. So we only use one browser. We're testing from one geographic location here on the West Coast. It might be that sites are, that on this geolocation we were going through some peering connection that was overloaded again. We're using one simulated network connection. In the real world, people have different network connections. They're going through different ISPs and mobile carrier networks. And the other thing is we're not doing any statistical smoothing techniques on this. So really, this synthetic measurement, you could improve the quality of that by adding more, by increasing the coverage of the variables. More browsers, web page test runs in 30 locations worldwide. We could spin up, if we had more money, we could spin up other data centers, other browsers, simulate other network connections, right? But we just can't do it at the scale that we're trying to approach. And so I pulled this timing chart, and I think in Joshua's study as well, it was using synthetic testing. I think it's just really hard with that synthetic testing to reflect what's happening in the real world. So that's why I really love the RUM data that Gomez and CompuWare were using in that earlier browser chart. Another problem in talking about how fast web pages are loaded is pretty much what people show is the onload time, window.onload, like you see here, and like you saw in that Gomez chart. And really, window.onload is no longer an accurate proxy for the user's perception of how fast a web page is loading, right? 5 years ago, when we were all doing Web 1.0, and we didn't have as much CSS and JavaScript, window.onload was pretty accurate. It fires after all the resources in the page are done loading, the images have rendered, the JavaScript is executed, people can engage with the page. Now we're lazy loading stuff, we're doing dynamic image requests using responsive images, we're lazy loading JavaScript, we have many more dynamic elements on the page that are rendered with larger amounts of JavaScript and CSS. And so it's really hard with window.onload to capture that experience. And I've got two canonical examples here to hammer this home. First is Gmail. If we look, I just did I loaded it 9 times. I just did one run on web page test. And the window.onload, the median was at 3.3 seconds. So in that sample test, this is what you see at 3.3 seconds. If we were tracking page load time using window.onload, this is what we would track. But this isn't ready. This isn't the page being ready. The user doesn't perceive. This is not the user's perception of how fast the page is. Instead, it's something more like this, where we see at 4.8 seconds, again, the median across those tests, we have about 90% of the page rendered, right? That really is the point at which we should measure page load time or page ready time, right? Unfortunately, there's nothing in the browser that tells us that. There's not a above the fold render time that you can get via JavaScript. We can do it here with the synthetic environment, and that's one of the advantages of synthetic testing. But you can see from this example, if we were tracking page load time, it's too optimistic. It's giving us a time that is much faster than the actual user's perception of the page being ready. Now on the flip side, let's look at Amazon. So we see that at about 2 seconds, the above the fold content is about 88% rendered, right? I don't know about you, for me, 88% is pretty much enough. I can start looking at the prices, reading the description, scrolling down, stuff like that. I can engage with the page after 2 seconds. But if what we were tracking was window.onload, that doesn't fire until 5.2 seconds. So here we have an example where window.onload is much too conservative. It's giving us a time that's more than 2x what the user's perception of the speed of that page is. And so what we really need is we need to move to a metric, a new performance metric, default performance metric, that is more about rendering and less about network transfer times, right? Because it's the content that's above the fold that really affects the user's perception, that affects the user's experience. So in web page test, Pat Meenan has put out a proposed metric. He calls it speed index. It's the average time at which visible parts of the page are displayed. So it's a number like 3257, and that's milliseconds. And what that means is at 3257 milliseconds, the median pixel on the page was drawn, right? So we can use this, and if you go to web page test and you run your test, you can see what the speed index is for the pages. And in fact, we're tracking that in that chart that you saw. We're tracking that in HTTP archive. And if you go to web page test and you run a test, it produces these film strips, and you can select multiple tests and get the film strips all next to each other. That's what I did here with Gmail on the top and Amazon on the bottom. And below each screenshot is a percentage number. That's the percentage of pixels above the fold that have been rendered at that point, according to this speed index metric. So we can see at 1 second, Gmail's actually ahead. It's got that progress bar. That's 28% of the pixels. Amazon has 0. But at 1.5, so somewhere between 1 and 1.5 seconds, Gmail has stayed the same. Amazon has jumped from 0 to 57%. At 2 seconds, Gmail is still the same. Amazon has jumped to 88%. So this is a really, really good way to track how your page is loading and what that perception of performance is going to be. And also in web page test, he plots this for you over time. So again, it's a great way to compare pages. What we can see is the red line, the Amazon line, is rendering pixels to the page at a much faster clip, right? So what I really wanted to do was to produce, so those are some stats about some synthetic testing and the need for some stat that takes into consideration rendering. What I really wanted to do today was publish some stats based on a very large data set that I have tremendous, tremendous faith in. Unfortunately, we were going to do that blog post today, and last week we realized today was April Fool's Day. Today's a great day for a blog post if it's a joke blog post. It's not a great day for a serious blog post. So I want you to look for that blog post tomorrow. What I am allowed to do is reveal some high-level stats and not the details. Overall, from this data set that I trust dearly, we saw that median page load times worldwide, based on a huge data set, got 3.5% faster, and on mobile they got 30% faster. And hopefully that will whet your appetite, and tomorrow you'll look for this blog post from Google, and I'll be tweeting about it. So let's look at our scorecard. Connections, getting faster, love that, especially on mobile. Browsers, going in the right direction, love that. I have confidence in that that's going to continue to go in the right direction. Pages are heavier. I have confidence that's going to continue to happen, but it's not a good thing for performance. So we've got to pay more attention to that and watch that with concern. Best practices are flat or maybe even trending down. And that's really disappointing for me. That's direct feedback on the quality of work that I'm doing. So I need to beat that drum harder, and we all need to pay attention to these best practices and drive the adoption up. And page load times are faster, and we'll get more precise numbers on that tomorrow. So what are the takeaways? Overall, I think the web is fast enough. And pretty much, we're done. We're not done. No one here is done. We're not leaving this room until we make the web faster. Okay, what are the real takeaways? This video growth caught me by surprise. I don't do a lot of video. A year ago, it wasn't registering besides Flash. Flash has been well contained over the last year, and this snuck up on me. So certainly I need to improve the charts in HTTP Archive to incorporate these new content types that are growing at a surprising clip. And we need to develop some best practices around video, compression, how we auto-load video or not. What are we doing on mobile? That really concerns me. This week I'm going to look at those stats on mobile. We need a better metric than window.onload. That's what pretty much everyone is looking at, and it's not really a good proxy for what the user experience is. So I appreciate Pat's work on speed index. We're going to look at that more. And we're already talking amongst the W3C Web Performance Working Group about a metric that we could have available in JavaScript in browsers that reflected above the fold content rendering. We need to evangelize these best practices better, all joking aside. They do work. They're not that difficult. We're working a lot with large content providers, content conduits like GoDaddy, DreamHost, WordPress. That will be one way, but the other way is for individual developers to maintain their familiarity with these best practices and to push them within their teams. Two areas that I just wanted to mention quickly that I'm looking forward to in the future for helping us with performance. One is now, even on mobile devices, we have multiple CPUs, dual core, quad core, and the more that the browser can offload some of the work it has to do to another thread working on another CPU is going to allow us to do more things in parallel as we load pages. So I'm very excited about the opportunities there. Certainly we can imagine something like a web worker being able to run on a separate CPU, but I think the browsers will figure out ways to go beyond that. And another area is caching. Michael mentioned this in his talk. Very excited last week to see Jonas Sicking from Mozilla put out a proposal for improvements to app cache and looking for feedback on that. So I think if we can improve caching and even prefetching, if we make browsers more intelligent, they can know what the user wants before the user indicates that and get that content local. I think that will provide us with faster experience on the web. So that's it. I wanted to put in one plug for Velocity happening in June. We'll be talking about this type of performance data there. Lots of tremendous speakers, including Kyle Rush talking about BarackObama.com. And that's it. Thank you very much.